Pressure: 1,000 atmospheres. Every living thing on Earth follows a biological blueprint. A way to breathe, a way to move, a way to sense danger. That blueprint works well on land. It works in shallow water. As you descend into the ocean, it starts to fail. Muscle weakens. Bones lose purpose. I stop being useful. The deeper you go, the less familiar life becomes. We are taught that life depends on sunlight, that complex animals need rigid skeletons, that pressure destroys cells and collapses proteins. Those rules hold until they don't. At extreme depths, there are organisms that feed on bone as their primary food source, creatures that detect prey without eyes, predators that kill without chasing, touching, or even being seen. This is not a place where life struggles. This is a place where life adapts in ways we were never meant to witness. Today, we are not cataloging strange fish. We are examining what happens when evolution is pushed into an environment where mistakes mean extinction. An evolutionary crime scene. Why does the deep ocean produce gigantism, turning small scavengers into animals the size of dogs? If pressure collapses proteins in laboratory tests, why do cameras still record movement at depths where cells should fail? And the most unsettling question of all, are these creatures disturbing by accident, or does their appearance serve a purpose? Prepare your oxygen. We are descending layer by layer into the deep ocean. Each zone strips away another rule of biology. And once we pass the point of no return, the light does not come back. Zone 1. The mesopelagic. We begin in the mesopelagic zone. This is the ocean's permanent dusk. Sunlight still reaches this depth, but it is weak, scattered, and unreliable. For a human, this environment is already hostile. Your lungs compress. Nitrogen begins to affect your judgment. Disorientation sets in quickly. For the creatures here, this zone is not hostile. It is optimized. Every adaptation is built around one problem: how to see without being seen. The stoplight loosejaw is a small fish, usually less than 10 inches long, with a body built for ambush rather than speed. Most animals at this depth are limited by vision. Their eyes are tuned almost exclusively to blue light, because that is all that penetrates this far. The loosejaw ignores that limitation. Beneath each eye is a specialized organ that produces red bioluminescent light. This light illuminates prey directly in front of the fish. At this depth, red light might as well not exist. Other fish do not see it. They do not flinch. They do not react. To the prey, nothing has changed. The loosejaw scans the water, highlighting targets in a wavelength no one else can detect. It observes behavior, distance, and movement without alerting anything nearby. Its lower jaw is connected by flexible ligaments rather than rigid bone. This allows it to open its mouth wider than its own skull. When it strikes, the jaw snaps shut with precision rather than force. The loosejaw does not chase. It studies, then ends the encounter in a single movement. The strawberry squid is named for the red spots that cover its body, each one a light-producing organ. What makes it truly unusual is its eyes. One eye is small and blue. The other is large, yellow, and permanently expanded. This asymmetry is intentional. The smaller eye is tuned to detect flashes of bioluminescence below, signals from prey or predators moving through darkness. The larger eye is tuned to gather the faintest traces of sunlight filtering down from above. The large eye functions almost like a telescope. It can detect silhouettes moving hundreds of feet overhead. The squid positions itself between two worlds, watching both at once. Nothing approaches without being noticed. In an environment where escape options are limited, early detection is survival. The hatchetfish has a laterally compressed body, meaning it is extremely thin when viewed from the side. From below, it is nearly invisible. Its eyes are large and permanently angled upward, forcing the animal to spend its entire life watching what passes overhead. Along its underside are rows of photophores, light-producing cells capable of precise control. These lights emit a soft glow that matches the intensity of the light coming from above. This technique, known as counterillumination, removes the fish's shadow. To predators below, the hatchetfish blends perfectly with the background light. To prey above, it is lost in darkness. It does not hide behind objects. It edits itself out of the environment. The fang tooth is small, rarely exceeding 6 inches in length, yet it possesses the largest teeth relative to body size of any known fish. Its mouth is filled with curved, needle-like fangs that extend beyond its jawline. The teeth are so large they cannot fit inside its mouth. The skull contains deep grooves that allow the teeth to slide into place when the jaws close. Despite its terrifying appearance, the fang tooth is not aggressive. It lives in an environment where food is unpredictable. Sprinting wastes energy. Chasing risks injury. Instead, it drifts slowly, muscles relaxed, metabolism low. When something comes too close, the strike is fast, controlled, and final. In the twilight zone, efficiency beats strength. At first glance, the barrel eye appears fragile and unfinished. Its most striking feature is its transparent head, a dome filled with fluid. Inside are 2 tubular eyes that point straight upward. From the outside it looks blind. From the inside, it sees directly through its own skull. These tubular eyes are extremely sensitive to light and optimized to detect faint silhouettes against the dim glow above. When prey is detected, the eyes rotate forward, allowing the fish to feed without moving its body. This reduces detection by predators. The barrel eye spends most of its life motionless, conserving energy, watching the world above it pass by. In the mesopelagic zone, survival is not about speed or strength. It is about perception. Who sees first? Who stays hidden longest? Who makes the fewest mistakes? Below this depth, light disappears completely, and the rules change again. At 1,000 meters, the sun is gone. Not dimmed, not filtered. Gone. This is the bathypelagic zone, often called the midnight zone. It is the largest living space on Earth, and it exists in permanent darkness. Pressure here exceeds 1,500 pounds per square inch. That is the weight of a refrigerator pressing down on every square inch of your body. For a human, death would be immediate and absolute. For life down here, the problem is not pressure. The problem is food. Meals are rare. Movement is expensive. Wasted energy is fatal. In this zone, hunger shapes everything. The black swallower is a small fish, usually no longer than 10 inches. Its body appears ordinary until it feeds. Unlike most predators, it does not specialize in prey of a certain size. It eats what it finds. The black swallower can consume prey up to 4 times its own length and more than 10 times its own weight. Its stomach is made of highly elastic tissue that stretches far beyond what seems physically possible. After feeding, the swallowed fish is often visible through the predator's transparent skin. Bones, fins, and eyes press outward as the body distends. The strategy is risky. If digestion cannot begin quickly enough, the prey starts to decompose inside the stomach. Gas builds. Buoyancy increases. Sometimes the black swallower is dragged upward by its own meal. As pressure drops, tissues rupture. The animal dies not from starvation, but from excess. In the deep, greed is just as dangerous as hunger. The gulper eel looks unfinished. Its body is long and thin, ending in a whip-like tail. Its head is dominated by an enormous mouth. The skull is hinged. The skin stretches like fabric. When fully opened, its mouth is large enough to engulf prey nearly its own size. It does not bite. It envelopes. The gulper eel lacks ribs and rigid bones in much of its body. This allows it to expand rapidly when feeding. At the tip of its tail is a small glowing organ that produces a faint pink light. The eel hangs motionless in the water, using the light as a lure. When something approaches, the mouth opens in a single movement, and the prey vanishes. No struggle follows. There is simply less space in the ocean than there was a moment before. Despite its name, the vampire squid is neither vampire nor true squid. It is a slow-moving animal built for survival in oxygen-poor water where most predators cannot function. When threatened, it does not flee. Instead, it turns itself inside out, wrapping its arms over its body and exposing spiny, glowing structures along its underside. The display is confusing and disorienting, making it difficult for predators to identify which part is edible. Unlike active hunters, the vampire squid feeds on marine snow. It extends long, sticky filaments into the water, collecting falling organic debris, dead plankton, fecal matter, microscopic remains of surface life. It survives where chasing prey would waste too much energy. This is not a predator built for violence. It is built for endurance. The female deep-sea anglerfish carries a glowing lure above her mouth. The light is produced by symbiotic bacteria housed inside a fleshy appendage. Prey is drawn toward the glow in total darkness. When it comes close enough, the jaws snap shut with speed that seems impossible for such a slow-moving animal. The males are tiny, sometimes no larger than a finger. When a male finds a female, he bites into her body and never releases. Over time, his tissues fuse with hers. His organs degenerate. His circulatory system merges with hers. He becomes a permanent source of sperm. In the bathypelagic zone, even reproduction is shaped by scarcity. At first glance, it looks like a pale eel drifting through the dark. Its most disturbing feature is what it lacks. It has no visible face. Eyes are reduced. The mouth opens downward beneath the head, hidden from view. From the front, it appears smooth and empty. The faceless cusk eel lives near the seafloor, feeding on small invertebrates and carrion. Its reduced facial features are an energy-saving adaptation. Vision is less important here. Sensory input comes from pressure changes and vibrations. In total darkness, identity becomes optional. In the bathypelagic zone, hunger replaces deception. Everything is shaped by the same question. When is the next meal coming, and how much energy can you afford to spend finding it? Below this depth, even scavenging becomes rare. Food no longer drifts freely through the water. It falls. And what waits below is built to endure long periods of nothing at all. Now we enter the abyss. At 4,000 meters, the ocean becomes a different world. The temperature hovers just above freezing. There are no seasons here. No storms. No tides you could feel. Only pressure. Only darkness. Only time. For a human, this depth would crush every air-filled space in the body instantly. Rescue would not be possible. Communication would fail. Sound would travel. But no answer would return. For the organisms here, the challenge is not survival. It is waiting. Food no longer swims past. It does not drift freely. It falls. And when it does, everything changes. On land, its relatives are pill bugs, small scavengers that roll into balls and hide under rocks. In the abyss, that same body plan grows to over 2 feet in length. The giant isopod has a thick armored shell, compound eyes, and powerful legs built for slow movement across the seafloor. This is abyssal gigantism. Cold temperatures slow metabolism. High pressure alters growth patterns. Scarcity favors animals that can store energy and survive long fasting periods. The giant isopod can go years without eating. When a whale carcass finally reaches the abyss, it becomes a once-in-a-lifetime event. The isopods swarm the body. They burrow into it. They consume muscle, organs, and connective tissue from the inside out. They do not rush. There is no competition here. Only patience rewarded. Ostax worms do not look like scavengers. They resemble delicate white plumes rising from the bone of a dead whale. They have no mouth, no stomach, no digestive tract. They feed on bone itself. Ostax secrete acid that dissolves the hard outer layer of whale skeletons. Root-like structures burrow deep into the bone. Inside their bodies, symbiotic bacteria digest fats and oils locked within the skeleton. A single whale fall can support these worms for decades. Entire ecosystems form around the bones of one dead animal. In the abyss, death does not end life. It sustains it. The sea pig is a type of sea cucumber, translucent and soft-bodied, with tube-like legs extending from its underside. It moves slowly across the abyssal plain in small groups. It feeds directly on marine snow that has settled into the sediment. Every flake of dead skin, waste, and organic debris that sinks from the surface eventually ends up here. Sea pigs ingest the seafloor itself, extracting nutrients and leaving processed sediment behind. Over time, entire herds reshape the abyssal landscape grain by grain. They do not hunt. They harvest the dead remains of the entire planet. Unlike shallow water octopuses, the Dumbo octopus does not jet through the water. It has small ear-like fins on either side of its head, which it uses to glide slowly above the seafloor. Its movements are quiet, gentle, almost delicate. In the abyss, speed attracts attention. Stillness survives. The Dumbo octopus feeds on worms, crustaceans, and small animals buried in the sediment. It does not ink. It does not camouflage rapidly. Instead, it relies on isolation. Predators are rare at this depth, and encounters are infrequent. In the abyss, being unseen is often enough. Some sponges in the abyss build skeletons made of silica, forming rigid, glass-like structures. These sponges can live for thousands of years. Small animals become trapped inside their lattice-like skeletons. Unable to escape, they die and decompose within the sponge. Over centuries, these sponges form reef-like structures on the seafloor. They create habitats that outlast most vertebrate species on Earth. In a place where change is slow, permanence becomes power. The abyss is not empty. It is patient. Everything here is built to last, to endure long stretches of nothing, and to exploit rare moments of abundance. But even this is not the limit. Below 6,000 meters, pressure reaches levels where chemistry itself begins to fail, where bones dissolve, where life should not function at all. And yet, something does. Below 6,000 meters, the ocean becomes something else. This is the hadal zone, named after the underworld. These depths exist only in trenches, long fractures in the Earth's crust, where the seafloor drops away sharply and keeps falling. Pressure here exceeds 8 tons per square inch. That is enough force to crush steel, deform electronics, and distort time-sensitive instruments. For a human body, existence would end instantly. For life, the problem is no longer darkness or food. It is physics itself. At first glance, the Mariana snailfish looks unfinished. Its body is pale, soft, and gelatinous. Its skin is thin enough that internal organs are faintly visible. It lacks heavy scales. Its bones are reduced and partially cartilaginous. At these depths, rigid skeletons fail. Calcium carbonate begins to dissolve. Proteins collapse under pressure. A fish should not be able to maintain structure here. The Mariana snailfish survives by saturating its cells with a compound called TMAO. This chemical stabilizes proteins, preventing them from folding and failing under extreme pressure. It does not resist the environment. It chemically aligns with it. In 2017, cameras recorded this fish at over 8,000 meters. It is the deepest living vertebrate ever confirmed. Hadal amphipods resemble small shrimp, but their bodies are tougher and more compact. They are among the most common animals found in trenches. When baited cameras descend into hadal depths, amphipods appear within minutes. They swarm in total darkness, stripping food down to bone with relentless efficiency. Their bodies are saturated with pressure-resistant compounds similar to antifreeze. They feed on anything organic that reaches the trench floor. Carrion does not linger here. It is erased. In the hadal zone, scavengers are often the dominant life form. Xenophyophores are single-celled organisms. Some grow larger than dinner plates. They live embedded in trench sediments, forming fragile, branching structures. Despite being single cells, they alter entire environments. They trap heavy metals, radioactive particles, and fine sediment inside their bodies. By stabilizing the seafloor, xenophyophores create microhabitats for smaller animals. Life here builds foundations out of organisms that should not exist at this scale. In the hadal zone, even the definition of complexity breaks down. These soft-bodied animals are distant relatives of sea stars and sea urchins. In trenches, they develop elongated, translucent bodies adapted to constant pressure. They move slowly across the trench floor, ingesting sediment and organic debris. Everything that falls eventually passes through them. Their tissues are flexible, compressible, and chemically stabilized. They do not rely on rigid structures. In an environment where crushing force is constant, softness becomes strength. The hadal zone is not barren. It is selective. Only organisms that surrender rigidity, abandon speed, and rewrite their chemistry can exist here. This is not the bottom of the ocean. It is the boundary where life negotiates with physics. At the deepest point on Earth, life does not fight the environment. It agrees with it. Everything you have seen survived by surrendering what we consider essential. Bones became optional. Speed became wasteful. Vision became irrelevant. These organisms did not evolve to be impressive. They evolved to be correct. Correct for pressure. Correct for darkness. Correct for a world that would erase us in seconds. What makes this unsettling is not how strange these creatures look. It is how complete they are without us. They do not fear the surface. They do not need the sun. They do not care that we exist. This planet did not evolve for humans. We adapted to a thin layer of air and light on its surface. Everything below learned how to survive without mercy. Every year we send machines deeper. Cables stretch across the seafloor. Mining plans reach into trenches. Sonar fills places that evolved in silence. We are entering environments shaped by pressure, patience, and scarcity. Environments that do not forgive disruption. We like to believe we are explorers. But from the perspective of the deep, we are intruders who do not understand the rules. And the most dangerous thing you can do in an unfamiliar world is assume it works like your own.